.NET 9 What is New in C# Concept, which was released in November. We'll explore a complete understanding of the new features introduced in C# 13. We will start with overview of the feature and then dive into each topic with practical example. Let's get started. These are the key topics we are going to cover. There are 10 new features and we will go one by one with example. Let's start with the parameters concept. What is new in the parameter? Previously, the param keyword only worked with the arrays, but now its capability have significantly expanded. The param modifier now can accept system span, a read-only span, and any type that implements enumerable. These changes provides developer with greater flexibility when passing collection to methods using the param keyword. It allows for more effective and versatile code, especially when working with the span and enumerable collection. So next we write one simple example how to implement this new feature params. Let's go to our Visual Studio. I have used the full demo in Visual Studio 2020 preview, but if you are using a different IDE, no worries. Just make sure you have .NET 9 installed on your PC. For the latest version of Visual Studio, make sure to check the .NET 9 is set up correctly. All right, let's jump to our first param collection demo. Here I have written function called print numbers, and the arguments defined as a param enumerable collection. This allows to pass the list of integers and the function simply print out the numbers. Let's see in the action. So here I define the set 1, 1, 2, 3. It's an integer array, and set 2 I define as a list 4, 5, 6, and third set I define the integer array 7, 8, 9. As I mentioned here, enumerable, I can simply pass the integer array like print numbers set 1. So here we passed as a array. Run this application. One, two, three gets printed for set 1. Fine. The next I pass the set 2 and set 3. Set 2 and set 3. Since it's an enumerable type, it accepts all the sets and print the result. Let's run this program again and see the action. 1, 2, 3, the first set, 4, 5, 6, second set, 7, 8, 9, third set. This is a simple example how to implement enumerable as a params. Let's go back to our PowerPoint. Our next topic is a method group. A method group is a collection of methods that share same name but differ in the parameters. Think of console.writeLine has a multiple overloads allowing you to write a different types of data to the console. Now let's look at how C# 13 make method groups more effective and reliable. First, enhanced type inference. The compiler is now much smarter at figuring out the correct delegate type for method groups. Second, scope by scope consideration. When resolving a method group, the compiler prioritizes instance methods over extension methods, ensuring clarity. Then invalid methods. If a method cannot be invoked, like one with invalid generic arguments, it's eliminated early and reducing the errors. And finally, the common signature requirement. A natural type is assigned to a method group only when all the methods share a common signature. To sum up, those enhancements in C# 13 make method groups easier to use and far more robust. If you've not tried them yet, now it's a perfect time. We jump into the demo and how to implement this method group. This program assigns the console.writeLine method group to two different delegate type, one for string and another one for char. Here the compiler resolve which console.writeLine method to use based on the parameter type specified in the delegate, string or char. In earlier versions, the compiler analyzed all overloads of console.writeLine and determined the best match for the delegates. In C# 13, the compiler quickly eliminates irrelevant overloads, making the process faster and more effective. We run this application and see the output. Here we cannot visually see the difference because it's a compiler optimization. So here the output. The next important feature is in the thread synchronization with the lock type. The lock type introduces a structured way to handle thread synchronization. It is not just more readable, it also includes advanced safety features released even in case of exception, significantly reducing the risk of deadlocks. So what benefit we'll get? The lock type makes your synchronization code cleaner, safer, and easier to understand. It is a step forward in clarity and control over thread management in C#. Let's jump into our Visual Studio. We see this threads synchronization with the lock type. Here I have written a sample program using parallel for each. There are 50 thread access the two function, one for old increment counter, another parallel for new increment counter. First, let's look into the traditional approach. Here, how we historically handle thread synchronization in C#. We use object keyword to ensure the only one thread can access the shared resource, our counter at a time. In this method, we wrap the critical session inside the lock block, passing an object, the lock object, for synchronization. While this works, there are few drawbacks. Let me explain the problem with this approach. Manual locking. Developers must carefully manage the locking scope, increasing the risk of mistakes and deadlocks. If the deadlock is mismanaged or nested improperly, deadlocks can occur which are hard to debug. We can run this application printing the numbers. Now let's move to C# 13 improved mechanism, introducing using the lock specific keyword for lock. And here we use a lock object with using the statement. This approach ensures that lock is automatically released at the end of the scope. No need to manually manage lock release. It's all handled by the framework. Let's run this application and see the output. Again, we cannot see the difference. It's completely based on the locking. Previously, initializing an indexer required extra code after the object was created for using this operator. But now you can directly initialize indexer as part of object initializer. So what are the key benefits here? Improved readability. Your code becomes cleaner and easier to understand since indexer elements can be directly set within the initializer. And simplified initialization. It eliminates the need for additional steps to configure indexer after creating the object. Enhancement improve both readability and maintainability, especially in scenario where indexer are frequently used. Within C# 13, writing more elegant and effective code just got easier. Time to move on our demo section. We'll switch to Visual Studio. First, let's look into the My Collection class, which defines the custom indexer. The class uses a private list item to store the data. The indexer defined in this keyword allows the object behave like an array. The get accessor retrieve the value from the index and the set accessor assign the value. Here is the interesting part. In C# 13 allows you to use indexer directly in object initializer. The key value pairs, 0th index we stored first and first index we stored as a value is a second, or added directly to the My Collection object. Let's run this application and see the output. And here we get the output to use the indexer. Let's talk about ref locals in async method. With C# 13, you can pass variables by reference into asynchronous methods. This avoids unnecessary copying of values, saving memory and improving performance. Next, we have an unsafe code in synchronous methods. Imagine working with the pointers directly for high performance needs. This is now supported in asynchronous methods and iteration. Lastly, iteration. You can now use ref in yield return, allowing effect iteration over large data structures without duplicating the data. This feature overall improves the performance of low-level programming and scenarios where memory optimization is critical. Let's jump to the Visual Studio. We implement this ref locals concept. In this program, I have defined int array and use the print array function to print the array elements. And here where the magic happens. We use a ref local directly reference an element of the array. The find number returns the reference to the element with a specific value. If you go to find number methods, search the array with a specified value and returns the reference to the element by using ref here. We enable direct access to the array element in the caller method. And here the return the reference to the found element, in our case 30, and it returns the reference of the array, and the next line we update the value. We run this application. The first we see this our original array. After calling this find number using the ref local, we update the value to 99, and again we print the result. First original array 30, 40, 50, and updated array, the line number 14 we updated 99, and this value here updated. So this is a simple example using ref locals. Let's move to our PowerPoint. Next we talk about overload resolution priority. The purpose of this attribute is to resolve ambiguity when new overloads are added. For example, you can guide the compiler to favor newer, more permanent methods while maintaining backward compatibility. It is super simple use. Just apply into the methods, constructor and properties. The attribute takes an integer value where higher number means higher priority. Here how it's work. During the overload resolution, if multiple methods are equally suitable, the compiler uses overload resolution priority as a tiebreaker to choose the method with the highest priority. Let's jump into the Visual Studio. We implement this overload resolution priority. This sample, I have defined a user-defined class myMax, and I have one function called add. It takes two arguments as a double and return value is a double to add two values. In the main program, here I call as add function, pass integer value here 5 and 3, and the next I pass as a double value 5.0.0.3.0. If you run this application, no issues, it will print the result, adding double 8, adding double 8, fine. Now I want to add a specific function to handle the integer value. Here, I write the function public static int x int y and adding two number and returning it. And here I keep the same code, I did not change anything. If I run this application, we are not sure which function get invoked. Maybe for integer values get called add function for integer, or maybe it call for double also. We are not sure. To implement this overload priority attribute, we can force to the compiler which function you take as a priority. Here I specify if it is integer value, you should call int only, not the double. To set this priority, I can use like this: overload priority. This one is a 1 I set, and here I set as priority 0. So what will happen when the integer value is calling? Compiler will check which is a priority 1. So for this case, add as a priority for integer. So it will take add a function as a high priority and execute this function. Double, of course, it will pick the double integer. Let's run this application and see the output. And here you can see adding two integer 8 and this one for the double. So this is a simple example to implement overload priority. Let's move to our PowerPoint slide. Next, we talk about XOR operator in object initializer. The XOR operator, also known as from the end operator, let you access the collection elements from the end during the initialization. This is a perfect scenario like reserve filling arrays, list, or spans. It simplified your code, making more readable and easier to understand. Plus, it reduced the chance of index calculation error. No more off by one mistake. With this, your code becomes not only cleaner, but also more maintainable, adjusting collection size. Let's move on to our Visual Studio. We write this XOR operator. This sample, I used the XOR operator to initialize the object elements from the end of the collection in this array. Here I had defined my int array. Here I defined the XOR operator, position 1, 2, 3. So this initialization take from the end. If I run this application, you can see the output. It will print 3 to 1 because the for each I go with the from start, but the initialize I did using the XOR operator from the end. We run this application and see the output. Here you can see the output. The object initializer using the XOR we define from the end 1, 2, 3. While printing, we go with the start. So it printing 3 to 1. This is a simple example how to implement this XOR operator. Let's move to our PowerPoint. In early version of C#, you could not use ref struct types as a type arguments for generic types or methods. This was a limitation for high performance scenario where stack allocated types as a crucial. With this C#13, this changed. Now you can add anti-construct to generic declaration, which implicitly allows ref type as a type arguments. Importantly, the compiler enforce all the rules on all instances of such type of parameters. The ideal use case for use this concept, requiring high performance with the stack allocated types in generic algorithm. This is a suitable one. Let's move on to Visual Studio. Here I have created structure, read-only ref structure rectangle. The read-only ensure that the structure is immutable, meaning its a field cannot be modified after installation. A ref structure keyword ensure that the structure is allocated on the stack, offering better performance for scenarios that need low-level memory management. The main advantage of using a read-only ref structure is a performance. Since the structure is allocated on the stack and heap, it avoids the overhead of heap allocation and garbage collection. This makes especially useful for scenarios where memory efficiency is critical, such as working with the large data sets or high performance application. However, there are some important restrictions using ref structure. You cannot store the ref structure in heap allocated object, such as in a class or in a list. This is because the lifetime of stack allocated variables is limited to the scope in which they are declared. In this structure, I have defined one function called calculate area. While creating the object for the structure, we need to pass the width and height. The calculate area function return the area of the calculation. Let's run this application and see the output. And here we get the output of the rectangle 200 based on our input. Let's move to our PowerPoint. You might already know about a partial class, which allow splitting a class across multiple files. This is great for organizing large classes or encrypting tool generated code. Now, C# take further with partial properties and indexer. You can declare like access modifier type or parameters in one part and implement the getter and setter in another. This is particularly useful when integrating with the source generator, as it allows generator code to define parts of property or indexer. The benefits are clear: better code organization, enhanced modularity, and easier maintainability for complex classes. Let's move on to our Visual Studio. We implement this partial for properties. Here we define the first part of the person class. It includes a partial property name and indexer. Notice the use of partial keyword. This means the full implementation of the member will be in part of another class. In the second part of person class, we implement the name property and the indexer. The name property uses a private backing field, name field, while the indexer works on an array of my array of integer. The key feature here is that name property and indexer are declared as a partial in the first part of the class and then fully implemented in the second part. This is a great way to organize your code across multiple files or logically separate concerns. Let's run this application and see the output. And here we get the output class. Let's move to our PowerPoint. Let's explore another exciting preview feature in C# 13, the field keyword, designed to simplify property logic and improve readability. C# provides concise properties with auto-generated private backing fields. The compiler is generated for you. Now the field keyword enables semi-automatic properties. This means you can define custom logic for either the getter or setter, still using the compiler backing field. The benefits are clear: less boilerplate code, better readability, and easier maintenance for property definitions. There are some important considerations while using this field keyword that we'll talk about in next slide. First, the field keyword is a private feature in C#. So you need to enable preview feature in your code project settings. Second, thoughtfully in many scenarios, fully automatic properties or managing defined backing fields. But for the case where you need a custom logic with minimal overhead, the field keyword is perfect fit for you. Let's jump to Visual Studio. We implement this field keyword. The field keyword, it's in the preview state. You cannot directly use C# 13 version. To use this feature, first you have to enable the preview field in the project settings. For that, go to the project settings file, and here you have to specify the lang version, that means language version preview. Once you set this variable as a preview, the field keyword get enabled. So in the person class, we have two property, one for name and another one for the age. The age property uses a new feature in C# 13, which is the field keyword. The set accessor uses a field. The field keyword refers to the backing field of the property, which is automatically generated by the compiler. In this case, it simplifies the code by eliminating the need to manually declare the backing field. Let's run this application and see the output. And here we get the output. Another feature, escape sequence. Use the escape sequence to represent the /e code. Why these changes is important? Let's break down it. It simplifies the code, eliminating the need for complex and less. Second, it improves the readability, making your code easy to understand. And finally, it reduces error, especially those caused by misinterpreting hexadecimal sequence. Let's jump to Visual Studio. This is a simple example how to implement this feature. This sample, the first line you can see, I used the hexadecimal to change the color. So this is the older way to implement this escape sequence character. And in the new way, I just replace this hexadecimal with /e, the new Unicode format. So it's more readable and less error prone. Run this application and see the output. So here we get the output of the program.